Lewis dot diagrams do not represent all the electrons in an atom. They represent only the outer electrons. So in other words, the ones in the last period of it. So they are called valence electrons. So that is just the outer period electrons that are represented in a Lewis dot diagram. An outlier diagram shows all the electrons, and electron configuration shows all the electrons, but a Lewis dot diagram only shows the outer period. Which of the following represents an oxygen atom using Lewis dots? Look at your periodic table. You will see that oxygen is in group 6. It's got 8 electrons, but it only has 6 in the second period, 2 in the s orbital and 4 in the p orbital. So your correct representation is going to be here, where I've got s, a pair in the p, a single in the p, and a single in the p orbital. Which of the following represents a potassium atom? You will see that potassium is number 19. 19 is actually in period 4, and it's in group 1. It only has 1 valence electron. So A is going to be my correct structure. Which of the following represents sulfur, a sulfur atom using electron configuration? Now, where is sulfur on the periodic table? You need to look at a periodic table, and you need to see that sulfur is in group 6 in period 3. So I'm looking for something that ends in period 3. So it's one of those two over here. And it has 6 valence electrons in total. So over here I need to count. Here I would have 2 plus 6, which is 8. 2 plus 4 is 6 valence electrons altogether. The other thing is to go to the periodic table and look at sulfur and go 1s2, 2s2, 2p6, 3s2, and then see that you've reached 3p and there are 4 electrons in that p orbital, and that's how you could do it as well. Which of the following represents a calcium atom? Now, calcium is number 20 on the periodic table. It's in group 2 and it's in period 4. So I'm looking for an outer energy level of 4. It turns out there's really only one. Sorry, just going back over here. This was your correct answer, B. And over here, you are going to land up with your correct answer being A, because it's got 2 electrons in the outer, the 4th energy level. Which of the following is a chloride ion? Now, that's a little bit more tricky. Chloride is Cl minus. Normally, it would have 17 electrons, but it's got 1 extra electron, so it's got 18 electrons. It is in group 7, but it's got an extra electron, and it's in period 3. So I'm looking for period 3. Oh, sorry, there it is. All of them seem to be in period 3, so that wasn't very helpful. And we're trying to look for a full outer energy level, so that is going to be represented over here by C. Which of the following represents a lithium ion? Lithium is normally number 3. But when it's an ion, it has lost 1 electron. It's in group 1, and it is in period 2. So it has, in group 1, it would lose 1 electron to become like helium. So we're going to minus an electron from there, and that means that it has got only 2 electrons. And how do I represent that? It's going to just be simple like that. Which of the following is not represented by this electron configuration? Well, neon is 10 electrons, 1s2, 2s2, 2p6. Sodium, the sodium ion, would normally be Na with 11 electrons, and it is in group 1, so it loses 1 of those electrons to become Na+, and it's then got 10 electrons, which is exactly the same as neon. So it's also going to be 1s2, 2s2, 2p6. What about the magnesium ion? Well, magnesium is normally Mg. There's 12. It's in group 2, so it will lose 2 electrons to become like its nearest noble gas, and once again, 10 electrons. What about fluorine as an atom? Fluorine has got 9 electrons. It doesn't say it's the fluoride ion. It's just fluorine, and therefore it will not have this electron structure, it will be 1s2, 2s2, 2p5. So fluorine is your correct answer.